guys, we are going to look at one of our division strategies in this video, and that strategy is called partial quotients. This strategy is also referred to as the chunking method, because what we're going to be doing as we divide these numbers is we're going to be taking large chunks away from our dividend and splitting it into groups of 3. So what I'm going to be doing today, I'm going to be doing two things. On this first page, I'm going to show you the strategy, while on the second page, I'm going to be showing you a model, kind of showing you why the numbers work out the way they do. So here's where we're going to put our model, where we're going to be dividing 426 by 3. Now, when you are doing a division problem, no matter what it is, whether it is you're splitting money or sharing t-shirts or passing out cookies, whatever it is, you're always asking yourself the question, how many each? That's what we're trying to figure out. How many each? Either how many in each group or how many groups of each. But you're trying to figure out how much is being distributed. So we'll go back to that strategy and we will get started. So why we love this strategy is because it allows us to do some of the hard work up front. So we're going to start by making a bank of our multiples of 3. So with our bank, I like to use a 1, 2, 5 rule, and I'll show you what that means. So as we take out these chunks from our dividend, we want them to be multiples of our divisor, which in this case is 3, because that's going to make splitting them by 3 very easy. So we're going to start by looking for some really large multiples of 3. So we're going to do 3 times 1, 3 times 10, and 3 times 100. So using that pattern helps us take a basic fact like 3 times 1 and find some really large multiples of 3. So there you go. Now we'll do the same thing with 2. 3 times 2, 3 times 20, and 3 times 200. Of course, 3 times 2 is 6, 3 times 20 is 60, and 3 times 200 is 600. It also really helps students really cement that place value understanding. You know, each time we add a 0, the digits move to the left. Finally, we're going to do 3 times 5, which is 15, 3 times 50, which is 150, and 3 times 500, which is 1,500. Now, that bank, again, is just really to help you start thinking about some multiples of 3 that you can use. And you can always go back and add more, always. So here we go. Now we'll set up our actual problem. We're going to do 426, and we're going to take our division symbol, and we're going to bring it really long like that, because that's going to allow us to record our partial quotients. Now, just like partial products, partial quotients are parts of the quotient that will be added together to find the final quotient. All right, so we're ready to begin. We're ready to look for that first big chunk to take from 426. And now for this example, I'm going to pretend like this is money. So I'm going to pretend like I have $426 that I want to split evenly between 3 people. It's going to help us think through what's happening here. So the first thing I tell students is to go to your bank, and we can eliminate products that are too big. Like, for example, if this really is money, and I only have $426 in my account, can I take out $1,500? No, I can't. So we can eliminate that. We're not going to need that. We're also not going to need 600, as they're just too big. So the next largest product that we have left is 300, and 300 would be a great amount to begin with, to chunk out from 426. So again, imagine I go to the bank and I say I want to take out $300. Well, do I have enough? I do. I have 426. So I'm going to go ahead and take that out. And, I also talk to students about how, you can also use the bank to think about what your partial products are going to be. Every single one of our partial products is going to be found by one of the numbers that we multiplied that 3 by. So in this case, when we chose 300 as our chunk, it tells us that the partial product for 300 would be 100. So that means that 300 is split into 3 groups of 100. Let's go to our model and see what that looks like. So again, I've taken 426, I've chunked out 300, so that means I'm going to give each person $100 to start with. Altogether it's 300. Separately they each have 100. But we still got some money left. Let's go back to our strategy and see what we have left. Alright, so when I do 426 and I take away the 300 I've already distributed, I'm left with 126. So now I really get to start all over. So instead of doing 426 divided by 3, I'm now doing 126 by 3. And, as students get better and better at this strategy, they really start looking at the relationship between these numbers. We want to look at the relationship between 3 and our dividend of 126, but we also want to hone in on that number 12, because I hope students realize that there is a relationship between 3 and 12. They know that 3 times 4 is 12. And if 3 times 4 is 12, we know that 3 times 40 is 120, which would be an excellent chunk to take away. Because, students, they could pull any of these numbers to chunk out, but we want them to become more efficient with time, so it takes less and less time to solve each problem. So we are going to chunk out 120. And so that means that, again, I'm going to the bank. I'm asking the banker to take away $120 from my account. And that will mean that when I distribute it, I think about how many groups of 3 that is, and that would, or how many would be in each group, that would be 40. So let's go back to our model and see what that would look like. If I take out $120 to share between 3 people, each person will get 40. Alright, I'm not done yet. Let's see what I have left now. So now I am left with 6. Now, it might be really tempting for students to say, hey, that's a single-digit number. I must be done. That must be the remainder. But we know that that's not the case. 6 cannot be the remainder when our divisor is 3. It's very, very important to remember that your remainder must be less than your divisor. If I'm trying to share $6 between 3 people, can I do that? Yes, of course I can, if that's still enough to make groups of 3. So in this case, I'm going to use 3 times 2, which is 6, to take out 6 and give each person 2. So this problem worked out really nicely. There's actually no remainder. There's no amount of money left. So the last thing I have left to do is to take those partial quotients, and actually let's go to our model, look at that first. So with my model, I'm going to pass out that last amount of money, that $2. And so essentially what we're saying is, we're answering that question, how many each? How much money did they each get? So in order to figure that out, we're going to add up our partial quotients. And this worked out really nicely. It was just expanded form. 100 plus 40 plus 2 is 142 with no remainder. So my quotient for the problem, 426 divided by 3, is 142. We can easily see that from our model as well. We can see that each person ended up with $142, and we can even check ourselves by adding those up. When you add 142 plus 142 plus 142, you get 426. But what they got each was 142. We always want to remember that relationship between multiplication and division. Alright, so that is the strategy for partial quotients. I'm going to go ahead and work one more. Just go through the strategy really quickly just so you can watch, okay? So I'm going to do 526 divided by 4. So you can watch as I do this step by step. Alright, I've got my bank, so I'm going to go ahead and set up my problem. Again, I'm going to eliminate those those products that are too big. And I'm going to get started. With 4 times 100 is 400. It's going to be a nice chunk to take out. When I do that, I'm left with 126. And I want to remember to write how many groups. In this case, it would be 100 groups. Alright, I'm going to look for my next chunk. 126. So there's a few that I could pull from my bank, but remember you can also add to the bank. So I'm going to add 4 times 30, which is 120. That would be 30 groups. I'm left with 6. So I'll ask again, can 6 be a remainder when the divisor is 4? The answer, of course, is no. I still have one more group of 4 to use. I'm going to take away 4, remembering that each person would get 1, and I am left with 2. So again, in order to figure out my final quotient, I'm going to add my partial quotients, which will give me a quotient of 131 with a remainder of 2. In this case, we did have a remainder. But our quotient for 526 divided by 4 is 131 remainder 2. Alright guys, thanks for watching.